Hi, welcome to our channel of IGNOU audiobooks, Indira Gandhi National Open University, School of Education, Master's Degree Programs, Master of Arts, Distance Education, MAID, Second Year, MDE, 415 Research for Distance Education, Block-3 Tools for Research, Unit 1 Methods of Sampling. Sampling 1.0 Introduction. In order to carry out a research study, you have to first acquire relevant information on the subject. In other words, you have to collect data. This data is required to test your hypotheses or generalizations that you have made for the time being. Let us suppose that as a researcher, you want to look into the relationships between study habits and achievement motivation of undergraduate students of IGNOU. For this, you have to select a few representative cases or samples from the entire population of undergraduate students of IGNOU. The process of selection demands thorough understanding of the concept of population, sample and various sampling techniques. In this unit, we shall familiarize you with the concepts of sample and population. We shall also discuss the characteristics of a good sample and the various methods of sampling. 1.1 Objectives. On the completion of this unit, you should be able to define the terms population and sample, describe the steps in the sampling process and the various methods of sampling, define a probability sample and describe the various types of probability sample, define a non-probability sample and describe the various types of non-probability sample, describe the characteristics of a good sample, and use computer softwares for the purpose of selection of sample. 1.2 Concept of population and sample. A sample is a miniature representation of and selected from a larger group or aggregate. In other words, the sample provides a specimen picture of a larger whole. This larger whole is termed as the population or universe. In research, this term is used in a broader sense. It is a well-defined group that may consist of individuals, objects, characteristics of human beings, or even the behavior of inanimate objects, such as the throw of a dice or the tossing of a coin. It is not possible to include all units of a population in a study in order to arrive at a valid conclusion. Moreover, the sizes of populations are often so large that the study of all the units would not only be expensive but also cumbersome and time-consuming. For example, there are more than 50,000 undergraduate students in IGNOU. For our research, it is impossible to collect information about the study habits of all these students. So, for the survey, a researcher will have to select a representative few, i.e., a sample, from the population. This process is known as sampling. If the nature of the population has to be inferred from a sample, it is necessary for the sample to be truly representative of the population. Moreover, it calls for drawing a representative proportion of the population. The population may contain a finite number of members or units. Sometimes, the population may be infinite, as in the case of air pressure at various points in the atmosphere. Therefore, a population has to be defined clearly so that there is no ambiguity as to whether a given unit belongs to the population or not. Otherwise, a researcher will not know what units to consider for selecting a sample. For example, we want to understand the study habits of distance education students. Here, the population is not well defined. We are not told about the universities that have to be included in this survey. After all, there are more than 100 universities in India that provide distance education, and there are 13 state open universities. Hence, to define it accurately, we have to specify the group as, say, undergraduate students of IGNOU. The second issue related to the representativeness of a sample is to decide about the sampling frame, i.e., listing of all the units of the population in separate categories. In the above study, there can be different sampling frames, such as male-female students, employed-unemployed students, etc. The sampling frame should be complete, accurate, and up-to-date, and must be drawn before selecting the sample. Thirdly, a sample should be unbiased and objective. Ideally, it should provide all information about the population from which it has been drawn. Such a sample, based on the logic of induction, i.e., proceeding from the particular to the general, falls within the range of random sampling errors. This leads us to the results expressed in terms of probability. A sample should not only be representative, but should also be adequate enough to render stability to its characteristics. What, then, is the ideal size of a sample? An adequate sample is the one that contains enough cases to ensure reliable results. If the population under study is homogeneous, a small sample is sufficient. However, a much larger sample is necessary if there is greater variability in the units of population. Thus, the procedure of determining the sample size varies with the nature of the characteristics under study and their distribution in the population. Moreover, the adequacy of a sample will depend on our knowledge of the population as well as on the method used in drawing the sample. For example, if we try to find out the study habits of undergraduate students of Lady Irwin College, Delhi, the population will obviously be more homogeneous than the population of undergraduate students of IGNOU with respect to socioeconomic status, employment of students or study hours available. However, it should be understood that the adequate size of the sample does not automatically ensure accuracy of results. 1.3 Methods of sampling. In the last section, we suggested that the method used for drawing a sample is significant to arrive at dependable results or conclusions. With this fact in view, here in this section, we shall now talk about the various sampling methods. Sampling methods can be broadly classified into two categories: I. Probability sampling, 2. Non-probability sampling. 1.3.1 Probability sampling. Probability sampling is based on random selection of units from a population. In other words, the sampling process is not based on the discretion of the researcher but is carried out in such a way that the probability of every unit in the population of being included is the same. For example, in the case of a lottery, every individual has equal chance of being selected. Some of the characteristics of a probability sample are: I. Each unit in the population has some probability of being selected in the sample. 2. Weights appropriate to the probabilities are used in the analysis of the sample. And 3. The process of sampling is automatic in one or more steps of the selection of units in the sample. Probability sampling can be done through different methods, each method having its own strengths and limitations. A brief account of these is given below. Simple or unrestricted random sampling. Simple random sampling is a method of selecting a sample from a finite population in such a way that every unit of the population is given an equal chance of being selected. See item I above. In practice, you can draw a simple random sample unit by unit through the following steps. I. Define the population. 2. Make a list of all the units in the population and number them from 1 to n. 3. Decide the size of the sample or the number of units to be included in the sample. 4. Use either the lottery method or random number tables to pick the units to be included in the sample. For example, you may use the lottery method to draw a random sample by using a set of n tickets with numbers 1 to n if there are n units in the population. After shuffling the tickets thoroughly, The sample of a required size, say X, is selected by picking the required X number of tickets. The units which have the serial numbers occurring on these tickets will be considered selected. The assumption underlying this method is that the tickets are shuffled so that the population can be regarded as arranged randomly. Similarly, while selecting 500 students from the total population of 50,000 undergraduate students of IGNOU, you will write the roll numbers of all the students on small pieces of paper. Jumble the chits well and then choose 500 roll numbers. The best method of drawing a simple random sample is to use a table of random numbers. These random number tables have been prepared. Fisher and Yates, 1967. After assigning consecutive numbers to the units of population, the researcher starts at any point on the table of random numbers and reads the consecutive numbers in any direction, horizontally, vertically or diagonally. If the readout number corresponds with the one written on a unit card, then that unit is chosen for the sample. Let us suppose that a sample of 5 study centers is to be selected at random from a serially numbered population of 60 study centers. Using a part of a table of random numbers reproduced here, 5 two-digit numbers, as the total population of study centers, 60, is a two-digit figure, are selected from table 1. Look at the screen. If you start with the first row and the first column, 23 is the first two-digit number, 05 is the next number, and so on. Any point can be selected to start with the random numbers for drawing the desired sample size. Suppose the researcher selects column 4 from row 1, the number to start with 83. In this way she can select first 5 numbers from this column starting with 83. Now, in selecting the sample of 5 study centers, 2 numbers, 83 and 75, need to be deleted as they are bigger than 60, the size of the population. The processes of selection and deletion are stopped after the required number of 5 units get selected. The selected numbers are 53, 40, 05, 33 and 01. If any number is repeated in the table, it may be substituted by the next number from the same column. The researcher will go on to the next column until a sample of the desired size is obtained. Simple random sampling ensures the best results. However, from a practical point of view, a list of all the units of a population is not possible to obtain. Even if it is possible, it may involve a very high cost which a researcher or an organization may not be able to afford. Therefore, simple random sampling is difficult to realize. Also, in case of a heterogeneous population, a simple random sample may not necessarily represent the characteristics of the total population, even though all selected units participate in the investigation. In the case of undergraduate students of the Open University in your country, assuming you have one, students may be employed in different sectors and categories of services industries. In spite of your best efforts, you may not be able to list all the categories of employment. In such a case, simple random sampling cannot help in representing all the categories under study. Systematic sampling provides a more even spread of the sample over the population list and leads to greater precision. The process involves the following steps. I. Make a list of the population units based on some order: alphabetical, seniority, street number, house number or any such factor. 2. Determine the desired sampling fraction, say 50 out of 1000, and also the number of the KTH unit. K is equal to N. N is equal to 1000 divided by 50 equals 20. 3. Starting with a randomly chosen number between 1 and K, both inclusive, select every KTH unit from the list. Now, In selecting the sample of 5 study centers, two numbers 83 and 75 need to be deleted as they are bigger than 60, the size of the population. The processes of selection and deletion are stopped after the required number of 5 units get selected. The selected numbers are 53, 40, 05, 33 and 01. If any number is repeated in the table, it may be substituted by the next number from the same column. The researcher will go on to the next column until a sample of the desired size is obtained. Simple random sampling ensures the best results. However, from a practical point of view, a list of all the units of a population is not possible to obtain. Even if it is possible, it may involve a very high cost which a researcher or an organization may not be able to afford. Therefore, simple random sampling is difficult to realize. Also, in case of a heterogeneous population, a simple random sample may not necessarily represent the characteristics of the total population, even though all selected units participate in the investigation. In the case of undergraduate students of the Open University in your country, assuming you have one, students may be employed in different sectors and categories of services industries. In spite of your best efforts, you may not be able to list all the categories of employment. In such a case, simple random sampling cannot help in representing all the categories under study. Systematic sampling provides a more even spread of the sample over the population list and leads to greater precision. The process involves the following steps. I. Make a list of the population units based on some order: alphabetical, seniority, street number, house number or any such factor. 2. Determine the desired sampling fraction, say 50 out of 1000, and also the number of the KTH unit. K is equal to N is equal to 1000 divided by 50 equals 20. 3. Starting with a randomly chosen number between 1 and K, both inclusive, select every KTH unit from the list. The mean average of these two samples would be significantly divergent as regards seniority and other associated variables. Many such samples can be drawn by taking different starting points, but there will be greater variation among them. Thus, the periodic effects and trend of the listed population unduly increase the variability of the samples, and calculations made from such samples cannot show the sources of variability. The main advantages of systematic sampling are: A. It involves simple calculations. B. It is less expensive than random sampling. Stratified random sampling. In some cases, the population to be sampled is not homogeneous. Therefore, rather than selecting randomly from the entire population, the main population is divided into a number of subpopulations called strata, each of which is homogeneous with respect to one or more characteristics. The sample elements are then selected from each stratum at random. Thus, all strata are represented in the sample. This approach to sampling is called stratified random sampling because the population is stratified into its subpopulations, and the condition of random selection is included by the selection within the strata. The steps involved in the stratified sampling are given as follows. I. Deciding upon the relevant stratification criteria such as sex, geographical region, age, courses of study, etc. 2. Dividing the total population into subpopulations based on the stratification criteria. 3. Listing the units separately in each subpopulation. 4. Selecting the requisite number of units from each subpopulation by using an appropriate random selection technique. Consolidating the subsamples for making the main sample. Thus, stratification improves the representativeness of a sample by introducing a secondary element of control. However, the efficiency of the stratified random sample depends on the allocation of sample size to the strata. There are three types of allocation. In stratified random sampling, 1 equal allocation. In this type, all strata contribute the same number of sampling elements to the sample. Thus, if there are 3 strata, 1/3 of the sample would be selected from each stratum. This type of allocation is done when strata have equal population too. Proportional allocation. In this type, all strata contribute to the sample a number that is proportional to its size in the population. The larger the stratum, the more members it contributes to the sample. The sampling fraction remains constant. Suppose there are 5 strata to be sampled and the respective population sizes of the strata are as follows, and 5% stratified random sample is to be selected. The proportional allocation will be done as follows. Look at the screen. Rendering proportional weightage to each criterion improves it further by allowing the use of a smaller sample and by helping in achieving higher efficiency at a reduced cost. 3. Optimum allocation. In optimum allocation, the strata contributions to the sample are proportional to the product of the strata population sizes and the variability of the dependent variable within the strata. Large strata and strata with large variability will have larger contributions to the sample. Because of the requirement of good estimates of population variability of dependent variable, which is seldom available before the sample is selected, the optimum allocation is used infrequently. Stratified random sample is useful when lists of units or individuals in the population are not available. It is also useful in providing more accurate results than simple random sampling. For example, while selecting a sample of undergraduate students of the Open University in your country, the researcher may decide the whole population of undergraduate students as males and females, north, east, south and west regions of the country, and then employed in government, private and autonomous institutions in the country. All these will be different strata. From each stratum, researcher may select 50 students as a sample. Sometimes stratification is not possible before collecting the data. The stratum to which a unit belongs may not be known until the researcher has actually conducted the survey. Personal characteristics such as sex, social class, educational level, age, etc. are examples of such stratification criteria. The procedure in such situations involves taking of a random sample of the required size and then classifying the units into various strata. The method is quite efficient provided the sample is reasonably large, i.e., more than 20 in every stratum. Cluster sampling. Cluster sampling is used when the population under study is infinite, where a list of units of population does not exist, when the geographic distribution of units is scattered, or when sampling of individual units is not convenient for several administrative reasons. It involves division of the population into clusters that serve as primary sampling units. A selection of the clusters is then made to form the sample. Thus, in cluster sampling, the sampling unit contains clusters instead of individual members or items in the population. For example, for the purpose of selecting a sample of high school teachers in a state, you may enlist all high schools instead of teachers teaching in high schools and select randomly a 10% sample, say, of the schools as clusters. You may then use all the teachers of the selected schools as the sample or randomly select a few of them. Any location within which we find an intact group of similar characteristics, population, members, is termed as a cluster. Examples of cluster include classrooms, schools, hospitals, and study centers. Cluster sampling is economic, especially when the cost of measuring a unit is relatively small and cost of reaching it is relatively large. Multistage sampling. Multistage sampling is used in large-scale surveys for a more comprehensive investigation. The researcher may have to use 2, 3 or even 4-stage sampling. For example, in surveys mailed questionnaires are generally used to gather information from people living in widely scattered areas. Although the method is cost-effective, partially completed questionnaires may introduce a bias due to which a representative sample cannot be obtained. To overcome this bias, two-stage sampling has to be used. A second sample from non-respondents is selected at random by contacting them personally. In this way, the consistency of the data obtained from the first sample can also be verified. Similarly, if a researcher goes for a national survey of counselors, he/she can draw a sample of 5 states representing northern, eastern, southern, western and central regions. From these 5 states, all the districts can be enlisted, out of which a sample of 30 to 40 districts can be drawn randomly. Out of this, all the study centers in different districts can be enumerated. A random sample of about 300 to 400 study centers is then drawn. Further, a random sample of about 1500 to 2000 counselors are drawn for the survey. The successive random sampling of states, districts, study centers, and finally counselors also provides a multistage sample. Multistage sampling is advantageous as the burden on the respondents is lessened, it is cost-effective, time-saving and efficient in formulating the subsample data. However, this method is recommended only when it seems impractical to draw a simple random sample. Probability proportion to size sampling. When the units vary in size, it is better to select a sample in such a way that the probability of selection of units is proportional to its size. For example, a particular study center has a population of 200 learners and another one has 100. While drawing a sample, the first study center will have double the representation as compared to the second study center. Such a sample is known as probability proportion to size sample or PPS sample. Using computer for sample selection, there are a number of websites that will generate random numbers for you. For example, website www.randomizer.org is very easy to use. On opening this website, you will have to answer a series of questions such as how many sets of random numbers to be generated, how many numbers per set to be produced, number range, etc. Many software packages include programs for selecting a random sample. One such package is Statistical Package for Social Sciences, SPSS, for Windows 15.0, SPSS, INC, 2006. SPSS has 2 options for specifying the size of random sample: A. Exactly, B. Approximately. Exactly, as the name suggests, requires exact specific number like 600 from 2000 class, 9 students listed. Whereas the second option specifies the sampling fraction, i.e. the ratio of sample size to population size, e.g. 30% of all the class 9 students could be selected. A number of other software packages are also available that provide the scope for the selection of a random sample other than a simple random sample. You may use any program following the instructions given in the manual for the software. 1.3.2 Non-probability sampling. Non-probability sampling, also called non-random sampling, refers to the sampling methods that do not have random sampling at any stage of sample selection. Since it is not possible to specify what probability each member of population has of being selected for the sample, the term non-probability sampling is also used for the same. This sampling is based on the judgment of the researcher. The guiding factors in non-probability Sampling include the availability of the units, the personal experience of the researcher, and his/her convenience in carrying out a survey. Since it is not possible to specify what probability each member of population has of being selected for the sample, these samples are known as non-probability samples. Depending on the technique used, non-probability samples are classified into incidental, quota and purposive samples. A brief description of these samples is given below. Incidental sample. The term incidental sample, also known as accidental sample or convenience sample, is applied to samples that have been drawn because of the easy availability of units. An investigator employed in the IGNOU may select learners enrolled in MDE program and who happen to visit the university for one or the other work while conducting a study on the perception of distance learners towards MDE. These learners are readily available and fulfill the conditions of the study. However, it is the limitation that though they have defined population but no randomization has actually been done. Therefore, any attempt to arrive at generalized conclusion in such cases will be erroneous and misleading. The merits of this procedure are mainly the convenience of obtaining units, the ease of testing and completeness of the data collected. Quota sample. Quota sample is another type of non-probability sample which is most often used in survey research when it is not possible to list all the members of population of interest. It involves the selection of sample units within each stratum on the basis of the judgment of the researcher rather than on calculable chance of the individual units being included in the sample. Suppose a national survey has to be done on the basis of quota sampling. The first step in quota sampling would be to stratify the population region-wise like rural, urban, administrative districts etc. and then fix a quota of the sample, i.e. how many, from each stratum, to be selected. In the initial stage, quota sampling is similar to stratified sampling. However, it may not necessarily employ random selection procedure in the initial stage in exactly the same way as probability sampling. The essential difference between probability sampling and quota sampling lies in the selection of the final sampling units. The quota is usually determined by the proportion of the groups. Suppose a researcher wants to study the attitude of university teachers towards distance education. First of all, he/she may stratify the university teachers in the category of sex and then as professors, readers and lecturers. Later, he/she may fix quotas for all these categories. In this way, the quota sample would involve the use of strata but selection within the strata is not done on a random basis. The data are obtained from the easily accessible individuals. Thus, members who are less accessible are underrepresented. The advantages of quota sampling are its being less expensive, convenient, and more suitable in the case of missing or incomplete sampling frames. Purposive sample. A purposive sample is also known as a judgment sample. This type of sample is chosen because there are good reasons to believe that it is a representative of the total population. The researcher selects a sample based on his/her experience or knowledge of the group to be sampled. For example, for study of gifted children, the researcher, on the basis of his/her past experience, selects certain individuals giving extraordinary performance in school while excluding all others from the sample. A purposive sample differs from convenience sample in that the researcher uses experience and prior knowledge to identify criteria for selecting the sample rather than selecting those who happen to be available. It is the clear criteria which forms the basis for describing purposive and defending purposive samples. Much of the sampling in qualitative research is purposive as the primary focus is on identifying subjects who can provide rich information for in-depth study about the particular topic and setting, not subjects who necessarily represent some larger population. Representativeness is secondary to the quality of the participants' ability to provide the desired information. Within the domain of purposive sampling are about 16 different types of specific approaches that may be used in qualitative researches. A few among these are random purposive sampling. When the purposive sample is larger than one can handle, one may select a required number of subjects from the purposively selected subjects. This is known as random purposive sampling technique. For example, if 20 potential participants were purposively identified by the researcher, but only 10 participants could be studied, a random sample of 10 from the 20 potential participants would be chosen. Snowball sampling, it involves selecting a few people who can identify still others who might be good participants for a study. For example, when interviewing members of a population, you can ask the interviewed persons to nominate other individuals who could be asked to give information or opinion on the topic. You then interview these new individuals and continue in the same way until the material gets saturated, i.e., you get no new viewpoints from the new persons. For example, a researcher wishes to study the opinion of distance learners towards quality of Gyanvani programs but can find only 5 who listen to these programs. She asks these students if they know any more. They give her several further referrals, who in turn provide additional contacts. In this way, she manages to contact sufficient Gyanvani listeners. Snowball sampling is most useful when we do not have access to sufficient people with the characteristics we are seeking, like in a situation when possible participants are scattered or not found in clusters. For such populations that are not well delimited nor well enumerated, for example the homeless, the drawback is that you get no exact idea of the factual distribution of the opinions in the target population. Besides, people usually propose people that they know well and who share their own views, which means that small groups of interest often are passed by unnoticed. One method for compensating this could be asking people to nominate both such persons who share the same views and such persons who are of the opposite opinion. Another method is to start the snowball chain from not one but several different people, perhaps from different social groups. Intensity sampling, this refers to selecting information-rich cases that manifest the phenomenon intensely and permit study of different levels of research topic but not extreme or deviant cases. For example, good students, poor students, above average, below average, experienced, inexperienced, distance tutors. Intensity sampling requires prior information and exploratory work to be able to identify intense examples. 1. Might use intensity sampling in conjunction with other sampling methods. For example, one may collect 50 cases and then select a subset of intense cases for more in-depth analysis. Homogeneous sampling, this refers to selecting participants who are very similar in experience, perspective, or outlook. This reduces variation and simplifies data collection and analysis. Like instead of having the maximum number of students enrolled in all professional programs offered through distance mode, it may focus on one program, say B.Ed. only. Stratified purposive sampling, this illustrates characteristics of particular subgroups of interest and facilitates comparisons between the different groups. Criterion sampling, here you set a criteria and pick all cases that meet that criteria or have some characteristic. For example, all distance tutors with 10 years of experience, all distance learners who dropped out from the formal system but completed the program through distance mode. This method of sampling is very strong in quality assurance, extreme and deviant case sampling. This involves learning from highly unusual manifestations of the phenomenon of interest, such as outstanding successes, notable failures. The non-probability samples are generally considered to be convenient when the sample to be selected is small and the researcher wants to get some idea of the population characteristics within a short time. In such cases, the primary objective of the researcher is to gain insight into the problem by selecting only those persons who can provide maximum insight into the problem. However, the following are some inherent limitations of non-probability sampling methods. No statistical theory has been devised to measure the reliability of results derived through purposive or other non-random samples. Hence, no confidence can be placed in the data obtained from such samples and results cannot be generalized for the entire population. 2. The selective sampling based on convenience affects the variance within the group as well as between the groups. Further, there is no statistical method to determine the margin of sampling errors. 3. Sometimes such samples are based on an obsolete frame which does not adequately cover the population. 1.3.3 Choice of the sampling method. The choice of sampling method depends on several considerations unique to each individual project. These include issues related to the definition of population, availability of information about the structure of the population, the parameters to be estimated, the objectives of the analysis including the degree of precision required, and the availability of financial and other resources. This calls for appropriate selection of a sample for the conduct of any research study. 1.3.4 Characteristics of a good sample. A good sample should have the characteristics of representativeness and 2. Adequacy. It is essential that the sample should be representative of the population if the information from the sample is to be generalized for that population. The term representative sample means an ideal miniature or replica of the population from which it has been drawn. In other words, the average of the attributes of sample elements is the same or very near to the average in the population. A good sample should also be adequate or of sufficient size to allow confidence in the stability of its characteristics. An adequate sample is considered to be one that contains enough cases to ensure reliable results. Hence, planning the size of the sample in advance is very important. It varies with the nature of the characteristics under study and its distribution. It may be mentioned that representativeness and adequacy do not automatically ensure accuracy of results. The sampling and data collection techniques need to be selected and employed carefully to obtain higher degrees of precision in results and generalizations about the population. 1.3.5 Determination of sample size. Most researchers find it difficult to determine the size of the sample. Craigie and Morgan, 1970, has given a table in which no calculations are needed to determine the size of the sample. Table is reproduced here for your reference. Table for determining sample size from a given population. Look at the SCREN. Let us take one example. If you want to know the sample size required to be representative of the opinions of 300 academic counselors, refer table at n is equal to 300. The sample size representative of the counselors in this case will be 169. The table given above is applicable to any defined population. Sample sizes in qualitative research are typically small. In fact, the validity, meaningfulness, and insights generated from qualitative inquiry have more to do with the information richness of the cases selected and the observational analytical capabilities of the researcher than with sample size. There are no definite rules to be followed, and determining adequate sample size in qualitative research is ultimately a matter of judgment and experience. Typically, one should continue sampling until having achieved informational redundancy or saturation, the point at which no new information or themes are emerging from the data. To know if the informational redundancy or saturation is reached, it is essential that data collection and analysis go hand in hand. In other words, data is collected and analyzed, at least in a preliminary fashion, side by side, and this analysis informs subsequent data collection decisions. 1.4 Key points at a glance. 1. A population is a well-defined group of units, individuals, objects, attributes, qualities, characteristics, traits of human beings, etc. 2. A sample is a small representation of a population. It is a miniature picture of the entire group from which it has been selected. 3. To obtain a representative sample, you must select the unit in a specified way. This process is called sampling. It usually involves the following 4 steps: I. Defining the population. 2. Listing the population. 3. Selecting a representative sample. And 4. Obtaining an adequate sample. 4. Sampling methods can be classified into 2 broad categories: I. Probability sampling and 2. Non-probability sampling. 5. In probability sampling, the units of the population are not selected at the discretion of the researcher but by means of certain procedures which ensure that every unit of a population has the same probability of being included in the sample. 6. Simple or unrestricted random sampling, systematic sampling, stratified sampling, cluster sampling, multistage sampling, and probability proportion to size sampling are the 6 main types of probability sampling. In all these types, each unit in the sample has some known probability of entering the sample. 7. In simple or unrestricted random sampling, each unit of the population is given an equal chance of being selected, and the selection of any one unit is in no way tied to the selection of any other. The law of chance is allowed to operate freely in the selection of such samples, and carefully controlled conditions are created to ensure that each unit in the population has an equal chance of being included in the sample. 8. The researcher may use the lottery method or a table of random numbers for drawing a simple random sample. 9. Simple random sampling ensures best results. However, it is neither feasible nor possible if the lists of the units do not exist or if such lists are incomplete. 10. If there is more heterogeneity among the units of the population, a simple random sample may not necessarily represent the characteristics of the total population. Even if all selected units participate in the investigation. 11. In systematic sampling, a researcher generally starts with a list in which all the n units of the population are listed in alphabetical or in any other order. To select a sample of size n, the researcher has to select a unit at random from the first k is equal to n units of the list, and then every subsequent kth unit is selected. 12. A systematic sample is as good as a simple random sample and is comparatively more convenient to draw. However, the characteristics of trend, cyclical fluctuations, and periodic effects of a listed population unduly increase the variability of samples. 13. When the units in a sample are proportional to their presence in the population, the sampling is said to be stratified. 14. When a population is stratified, the units within each stratum are more or less homogeneous than the units within the entire population. 15. Stratified random sampling is very useful when lists of units or individuals in the population are not available. This method has been found practical even for small finite populations when % response is difficult to secure within the desired time. 16. Stratified random sampling provides more accurate results than simple random sampling only if stratification results in greater homogeneity within the strata than in the whole population taken as one unit. It is particularly useful in opinion survey studies. 17. Cluster sampling is used when the population under study is infinite, where a list of units of the population does not exist, when the geographical distribution of units is scattered, or when sampling of individual units is not convenient for various practical purposes. 18. Cluster sampling involves division of the population of elementary units into groups of elements or clusters instead of individual members or items in the population. 19. Cluster sampling is economical, especially when the cost of measuring a unit is relatively small and cost of reaching it is relatively large. 20. Multistage sampling is used in large-scale surveys for a more comprehensive investigation. In this type of sampling, the researcher may have to use 2, 3, or even 4 stages of sampling. 21. Multistage sampling is comparatively convenient, less time-consuming and less expensive. However, an element of sample bias gets introduced because of the unequal size of some of the selected subsamples. 22. When the units vary in size, it is better to select a sample in which the probability of selection of a unit is proportional to its size. This sample is known as probability proportion to size sample or PPS sample. 23. Non-probability sampling is based on the judgment of the researcher. Its guiding principles are I. Availability of sampling units, 2. Personal experience of the researcher, and 3. The researcher's convenience in conducting the research. Since this type of sampling does not involve the principle of probability, it is called non-probability sample. 24. Non-probability sampling provides I. Purposive samples, 2. Incidental samples, and 3. Quota samples. 25. A purposive sample is arbitrarily selected because there is good evidence that it is a representative of the total population. The evidence is based on researchers' experience. 26. An incidental sample is generally used with those groups which are selected because of the easy or ready availability of sample units. 27. A quota sample involves selection of the sample units within each stratum or quotas on the basis of the judgment of the researcher rather than on calculable chance of being included in it. 28. Non-probability samples are very convenient in situations where the sample to be selected is very small and the researcher wants to get some idea of the characteristics of a population in a shorter time. 29. Non-probability samples have certain limitations. No valid generalizations can be made beyond the sample studied. These samples depend exclusively on uncontrolled factors and the researcher's insight. Hence, the sampling error of such samples is hardly determinable. 30. The choice of an appropriate sampling method by a researcher depends upon many factors. These include I. Defining the population, 2. Availability of information about the structure of population, 3. The parameters to be estimated. 4. The objectives of the analysis including degree of precision required and the availability of financial and other resources. 31. Representativeness and adequacy are the major characteristics of a good sample. 1. 5. Summary. In this unit we discussed the concept of population and sample and the two methods of sampling, namely probability and non-probability sampling. Under probability sampling, we discussed its various types such as simple sampling or unrestricted random sampling, systematic sampling, stratified sampling, cluster sampling and multistage sampling. Under non-probability sampling we discussed purposive sample, incidental sample, quota sample, and also touched upon the choice of sample. We ended this unit with a description of the characteristics of a good sample, representativeness and adequacy. Thank you. Subscribe to our channel for more updates, and we will see you with the next chapter.